Good morning, my dear students of class 12. Today, I'll make you understand how to derive different calculus, calculating values of calculus and the derivation of different forms. So, before going to next stage in integral calculus, we should not forget of a great mathematician. He is Bernard Riemann. So Bernard Riemann was a great mathematician who has calculated areas under the curves using rectangular values or using the process of rectangle. So let us start with our integral calculus. The very first form is in this type. So let us put here x is equals to sine theta. Then differentiating both sides, we get dx is equals to cos theta d theta, right? Now from here we can take it as a square minus x square is equals to a square minus, okay, let us take x is equals to a sin theta here, then it becomes a cos theta here, then a square minus x square is equals to a square minus a square sin square theta, which is equals to taking a square as a common, 1 minus sin square theta, which is equals to a square cos square theta. Now using these values in this, so this integrating 1 by root over a square minus x square dx. See here, so instead of dx we can put a cos theta d theta. So we are writing a cos theta d theta by a square minus x square is this, so root over this will be a cos theta, cancelling out, we get integration of d theta is theta, but we know that x is equals to a sin theta, bringing out here x by a is equals to sin theta, therefore theta is equals to sin inverse of x by a. So here we can write here sin inverse of x by a. Clear? Now integration of the form 1 by root over a square plus x square. We know that 1 plus tan square theta is equals to secant square theta. So instead of x, let us put x is equals to a tan theta, then dx becomes, differentiating becomes a secant square theta d theta, where let x is equal to a tan theta we have, so this a square plus x square can be written as in the form of this. So our next step will be 1 by root over a square plus x square can be written as a square secant square theta, and dx can be written as into a secant square theta d theta, which implies this gets cancelled off with this, so a secant theta and a secant square theta gets cancelled, so we get only secant theta d theta. My dear students, already we have done the integration of secant theta. The integration of secant theta is log of secant theta plus tan theta. So we can write here log of secant theta plus tan theta. Now we have to find out the value of secant theta plus tan theta. So how can we find out the values in terms of this? So let us first, we have taken x is equals to a tan theta. Let us make a right angle triangle in this way. Here x is equals to a tan theta, that means x by a is equals to tan theta. Let us make here theta a b c. See here, we know that some people have curly brown hair till paint it black. So this can be considered as x, this is as a, then this becomes a square plus x square. Now we know that the value of tan theta is x by a, so but we have to find out the value of secant theta. We know that secant theta is 1 by cos theta, and we know that cos theta is, some people have curly brown hair, this by this. So a by root over a square plus x square is cos theta. So what will be the secant theta? Secant theta will be root over a square plus x square by a from this. So here final answer we can write here log, instead of secant theta we are going to write on this, that is root over a square plus x square by a plus, what is tan theta? Tan theta is x by a. So this is x by a. In this way we can form the integral of 1 by root over a square plus x square. Clear? So one more integration of the form root over 1 by root over x square minus x square dx. See here, we know that 1 plus tan square theta is equals to secant square theta. Therefore, secant square theta minus 1 is equals to tan square theta. So considering those things, we can take x is equals to a secant theta, then differentiating both sides, we get on the form this. Also, x square minus x square can be written in the form of this. Since root over x square minus x square is root over this, if root over this is, the final answer will be a tan theta in the denominator. So considering this, we get dx, instead of dx we can write this, that is a secant theta tan theta d theta whole divided by this can be written as this, that is a tan theta. So we are getting cancelled off. So finally we are getting integration of secant theta d theta. We have already know that one. The answer is log of secant theta plus tan theta. Now we will try to find out what is the value of secant theta plus tan theta when x is equals to a secant theta. So let us make a right angle triangle again. If this is theta, then x by a secant theta is equals to x by a. That means 1 by cos theta is equals to x by a. That means cos theta is equals to a by x. So again, some people have curly brown hair. So this is a, this is x, then this will be, we know that by the help of Pythagoras theorem in a right angle triangle, then this will be x square minus a square. So we know the value of secant theta is x by a. So instead of secant theta we can write here x by a log x by a plus, what is tan theta? We know that the tan theta is, some people have curly brown hair till painted black. That means this by this, that is root over x square minus a square by a. In this way, you can get the value of this integration. Thank you. So one more form of integral is root over a square minus x square. So let us keep here x, substitute here x is equals to a sin theta. Then differentiating we get dx is equals to a cos theta d theta. So let us write this as integration of root over a square minus x square is a square sin square theta. Instead of this we write this a cos theta d theta. This becomes, from this we can take the common of a square into one minus sine square theta into a cos theta d theta. This becomes 1 minus cos sine square theta is cos square theta, a square cos square theta. Under the root, if you take out the root, it becomes a cos theta into a cos so which becomes a square cos square theta d theta. Now a square is a constant, we are going to take it out and we have to find out cos square theta. So my dear students, now to find out the value of integration value of cos square theta, we know that cos 2a is equals to cos square a minus sin square a. So cos square a can be written as in terms of cos 2a as cos 2a minus, this minus comes this side, becomes plus sin square a is equals to cos square a. Again we know that sin square a can be written as 1 minus cos square a. So we can write here cos 2a plus 1 minus cos square a is equals to cos square a. If you take this side here, it becomes 2 cos square a. So finally we get cos 2a plus 1 by 2 is equals to cos square a. So instead of cos square theta, we can write here cos 2 theta plus 1. So finally we get here a square integration of bracket cos 2a plus 1 divided by 2 d theta. So now we'll split this and try to find out the answer. So in the last we had this, so this can be written as, if we split up, we get a square by 2 cos 2 theta and a square by 2 into d theta. So finally, if you integration of this is this and integration of this is this, this can be written as a square, since sin 2 theta is equals to 2 sin theta cos theta. So instead of sin 2 theta, we can write here 2 sin theta cos theta, that is into 2 sin theta cos theta divided by 2. This gets cancelled off, plus a square by 2 theta. Since x is equal to a sin theta, so theta is equals to sin inverse x by a. Now we know the value of sin theta, but we have to find out the value of cos theta using one sin square theta plus cos square theta is equals to 1. If you find out, then the value of cos theta will be this. That is cos theta is equals to root over a square minus x square by a. Therefore, from here, instead of cos theta, we can write this. So finally, we get here a square instead of sin theta. Instead of sin theta, we can write here x by a into cos theta. We can write here root over a square minus x square by a plus a square by 2 sin inverse x by a. Now here a into a is a square, this gets cancelled off. So finally we get x root over a square minus x square plus a by 2 sin inverse x by a. Sorry, it's here it is a square, so we write here a square. Okay, for the next two derivation of integrals, let us go with certain hyperbolic function. Generally we have in ordinary we have learned in class 9, 10 that sin square theta plus cos square theta is equals to 1. So in the same way, for the hyperbolic function, the forms are hyperbolic square of this minus square of this is equals to 1. This is number 1, you have to know it very carefully. Then cos h 2 theta is equals to this, then cos h square theta is equals to this, you have to know it, this formula also. And finally, sin inverse of x by a is equals to log x plus root x square plus a square. And for cos, is just instead of here plus, you are going to write down here minus. Now it becomes very simple to derive the next two integrals. Just you have to assume certain things which I am going to say it. Okay, now another form of integration is integral of root over a square plus x square dx. In this, we have to assume x is equals to a sine hyperbolic function of theta, then dx is equal to a cos theta, and finally, if you go proceed out with this, the answer of this will be this. Similarly, instead of a square plus x square, if it is x square minus a square, only this gets reversed up, nothing else, and instead of plus we are getting here minus, and instead of plus we are getting here minus. But here we have to assume x is equals to a cos theta, then dx is equals to a sin hyperbolic function of theta d theta. From here, if you put the values over here, by substituting this, we can get the final answer here. So these are today, whatever the classes we had for the 6 different integrals is the most important definite integrals which you have to learn in your class.